Hi AP Chem class, this is Mr. Mellinger, and this is the first of the solutions videos that you'll be getting in this class each day to show you how to do the problems that are assigned in class. And the idea is that you don't sit home frustrated by yourself trying to do a problem you just don't know how to do. So I do provide you with solutions videos. It's your job though to try to think through a problem first before going to the solutions video. There are a few problems, such as the one you see right here that says check, that I will not give you the solution to, and that's one that I'll check when you turn in your homework. But most problems, probably 90% of the problems, 80 to 90%, I will give you the solutions to. This first assignment is pretty straightforward, and for most of you this won't be a challenge. It's just to work on some basic math skills that you're going to need for chemistry. And let's go ahead. Now let me tell you about these solutions videos. You don't have to watch them. If you know how to do the problems on your own and you're sure you're doing them right, then you go ahead and just don't have to watch this video. Or you don't have to watch it from beginning to end. If there's one problem you don't know how to do, just skip through the video till you're going to have to do it by trial and error, but skip through the video till you find that problem. You may not want to listen to my voice for any long period of time, so you're welcome to mute the voice and just watch the solutions being done. Or if you want, you can just go as I say, to a particular problem just to find out what the answer is if you just want to check for it. There's a lot of ways you can use this video, but you do not have to watch it from beginning to end. Having said that, let's get started. We're going to work on fraction multiplication first. Fraction multiplication, you multiply straight across the top, which is called the numerator, straight across the bottom, which is called the denominator. You do not cross multiply. Some students get fractions confused with proportions. We'll talk about those some other time, but this is the way that you multiply. So 2 times 9 is 18, and 3 times 10 is 30. Now those are both even numbers, as you can see, so you know you can divide them both by 2. You can reduce them. Never leave a fraction in unreduced form. Okay. And let's go ahead and reduce this. So 2 goes into 18 9 times, goes into 30 15 times. And now I think all of you can see that 3 goes into 9 3 times, and goes into 15 5 times. Can't reduce 3/5 any further, so that's your final answer. Now the preferred way to do a fraction is to cancel before you multiply. If you don't, this number right here could end up being a very large number, both numerator and denominator. So let's rewrite the problem. Okay, now I'm going to see what cancels. Now this 2, I can either cancel with the number directly below it, if it's possible to do so, or with the number across the times sign. This has to be a times sign. It cannot be a plus sign, a minus sign, or a division sign. It has to be a times sign. Similarly, the 9, I can either cancel with the number below it if that's possible, or I can cross the times sign and cancel it with that. So 2 we see goes into 2 1 time, and 2 goes into 10 5 times. 3 goes into 3 1 time, goes into 9 3 times. So now we multiply straight across. 1 times 3 is 3. 1 times 5 is 5. And as you of course see that we came up with the same answer both times, okay? But this way is the preferred way to do these problems. All right, let's do this one. Go ahead. What I'd like you to do is pause the video. I'll give you a couple seconds to do that, and then turn it back on when you think you've done the problem, and you can check to see how you did. Okay, and we're back. So we're going to see what cancels here. Well, I know that 3 goes into 27 9 times. 3 goes into 30 10 times. Now, I've already canceled this to reduce it to a 9, but I can still reduce it again. 3 goes into 9 3 times. 3 goes into 12 4 times. So now I multiply straight across. 3 times 21 is 63. And 4 times 10 is 40. And that's your final answer. Now this is called an improper fraction when the number on the top, the numerator, is bigger than the denominator. What you can do with an improper fraction is change it to a mixed fraction, and I'm not going to show you how to do that right now. I'm just going to do it to show you what it looks like. You're familiar with this even if you don't know it by that name. Now, students want to know, do you have to convert this to this in this class at least? In this class, the answer is no. If you're going to do further work with this fraction, it has to be in this form. It cannot be in mixed fraction form. You can't do math with a mixed fraction. You would have to convert the mixed fraction back to this. So as far as I'm concerned, you can just leave it as an improper fraction like that. Okay? All right. Let's go ahead and do the next one. Pause. And we're back. And what cancels here? 13 goes into 13 once. It goes into 26 two times. Now 16 doesn't go into 20, but 4 goes into both of these numbers. It's the largest number that does. So 4 goes into 16 4 times, goes into 25 times. So now we multiply. 4 times 2 is 8, and 1 times 5 is 5. And again, that gives us another improper fraction. You can just leave it like that, and that's your final answer. Okay, this next one I'm going to leave for you to do, and I'll check that one as part of your homework. Okay. Next, let's move on to fraction division. So you're dividing a fraction by another fraction. And so how do you do that? Well, you've probably heard various rules of thumb on how to remember that. It's keep, change, flip, or it's invert and multiply, or flip and multiply. And what it means is you flip the bottom, and then you multiply that by the top. So we keep the top the same. That's going to be 2/5. Times the bottom flipped over, so it's 7 over 3. Okay, we check to see if anything cancels, and nothing cancels, so we go ahead and just multiply straight across. 2 times 7 is 14, 5 times 3 is 15, and that's our final answer. Okay, why does this work, this flip and multiply thing? Well, let's just take a simple example. What's 6 divided by 2? Well, we know that equals 3. We could have also written that as 6 over 2. That's just another way of writing 6 divided by 2, and that equals 3. All right, that's the same as 6 times the reciprocal of 2. What's the reciprocal? Well, if I take 2 and I put a 1 underneath it, because that's still 2, the reciprocal of that means you flipped it, is 1/2. So dividing by a number is the same as multiplying by its reciprocal. So 6 times 1/2 is 1/2 of 6 is 3. So whether we say 6 divided by 2 or 6 times the reciprocal of 2, 1/2, we get the same answer. So by taking the reciprocal of this and multiplying this by the reciprocal of this, it gives us the answer. That's why flipping works. Okay, let's go ahead and do this one. Pause. And we're back. 6 over 7 times 14 over 3. Okay, and everything cancels here. 3 goes into 3 once, into 6 twice. 7 goes into 7 once, into 14 twice. Multiply straight across. 2 times 2 is 4. 1 times 1, that is a 1, is 1. And of course you don't write 4 as 4 over 1, you just write it as 4. Alright, move on. Do this one. Pause. And we're back, and I'll just do this one silently. Okay, and finally this last one is going to be a check problem for you. Okay, now we're on set 3, it's on the second page, and what we're going to do now is we're going to divide a whole number by a fraction, or a fraction by a whole number. It's essentially the same as what we just did, but there's one step added. You first have to turn the whole number into a fraction. So let's just read the instructions. Dividing a fraction by a whole number requires converting the whole number into a fraction by placing a 1 underneath it. Okay, so we're going to take this 3 before we do anything else and put a 1 underneath it, and we're going to turn that into a fraction. And then the 6/7 on the bottom doesn't change. So now what we're going to do is take the 3 over 1 and multiply it by the reciprocal of 6/7. So that's 7 over 6. And we can do some cancellations here. 1 there, 2 there. And that gives us an answer of 1 times 7 is 7. 1 times 2 is 2. And there's our answer. Okay? All right. Let's go on down to this one. Now this one is essentially the same. It's just that the whole number's on the bottom rather than on the top. It's done the same way, however. Let's go ahead and do that. 7 over 8. Divided by 21 over 1. Okay, so now we're ready to flip and multiply, and that equals 7 over 8 times 1 over 21. And we can cancel the 7. 7 goes into 7 once and into 21 3 times. And you multiply top. 1 times 1 is 1. 8 times 3 is 24. And there is your answer for that. Okay. All right. Go ahead and do the last two. Do them together. Just go ahead and do them at the same time and pause right now to do that. Okay, and we're back, and I'm going to do the final two silently. Okay, and that takes care of fraction division. We don't do much, if anything, of fraction addition and subtraction in chemistry, but we're going to go ahead and do it here, do a few problems just to complete the thought. So adding and subtracting a fraction requires a common denominator. That denominator is the bottom. That means those two have to be the same number. That's what common denominator means. What you do is you multiply the top and bottom of each fraction by the denominator of the other fraction. So what you do is this. You take this 5, you roll it over here, and you put it on the top and on the bottom. Okay? And you're going to multiply this, and you're going to multiply that. Is that legal? Can you do that? Actually, let me just put this in parentheses. Is that legal? Well, sure. 5 over 5 equals 1. So 2/3 times 1 still equals 2/3. You haven't changed the value of the 2/3. So yes, that's legal. We do the same thing over here. My equal sign's in the way here, so I'm just going to scratch over it. So I have a 3 on the top and a 3 on the bottom. And just put that in parentheses. So again, 3 over 3 equals 1. So 4/5 times 1 still equals 4/5. But the numbers are going to look different, but they're still going to hold the same value. So let's do these 4 little multiplications. 5 times 2 is 10. 5 times 3 is 15. Plus 4 times 3 is 12. And 5 times 3 is 15. So you see we ended up with a common denominator there and there. And 10/15 is 2/3. 10 is 2/3 of 15. And 12/15 is 4/5. 12 is 4/5 of 15. So we didn't change the value of the fraction. Okay, now to finish the problem, you add the numerators but not the denominators. So 10 plus 12 is 22. And then 15 stays on the bottom, and that is that. Okay, let's go ahead and do this subtraction problem here. So again, I'm going to do the crossing arrows. You don't have to draw these arrows. It's just a mnemonic device. That's a memory device to remember the process for doing this. I'm going to bring the 3 over here. Again, I'm going to have to scratch out my equal sign there. Okay, same situation as above. I'm going to write it over here because of space. So 4 times 7 is 28. 4 times 3 is 12. Minus 5 times 3 is 15. And 4 times 3 is 12. Common denominator. And now you just subtract the numerator. 28 minus 15 is 13. and the 12 stays the same, and that is your answer. Okay, go ahead and do the last two. Do them together, do them at the same time, and then we'll resume and I'll solve both of them. And so pause. Okay, and we're back. So I'm going to do these silently. Okay, so don't let the negative trick you. It's just the same as any other subtraction that gives you a negative number. Okay. All right, now we're going to move on to decimals. In chemistry, in AP Chem, you are going to get to use calculators all the time. However, you got to be sure you understand the math fundamentals in case there is a time when you have to either check your work or just have to do something by hand. It does happen. So we're going to add some decimals now. In adding and subtracting decimals, you line up the decimal point. So I intentionally wrote them side by side so you would have to line up the decimal. So this one here is going to be 43.67. And we're going to add to that 3.2. So the decimal point has to line up with this one. The 3 is immediately in front of it. The 2 is immediately after. This empty space here, if you want, you can put a 0 there. And now you add. And you get 7 and 8 and 6, that's bigger, and 4. Okay, and that's your answer. All right. Okay. Let's go ahead and do this one down here. It's a subtraction. Same thing. You line up the decimal point. So go ahead, pause. Try to do this one on your own. And we're back. So you have 8.9 minus 0.287. Again, wherever you see these blank spaces, if you want, you can just fill them in with zeros just to line them up. Okay, and now we subtract. It's always tricky to do subtractions, with zeros on the top. So I'll show you a way to check your work, because I get fooled by these sometimes. So 0 minus 7, you're going to have to borrow a 1, but this guy doesn't have a 1 to loan. You're going to have to come all the way over here. This guy's going to loan a 1 to this guy. He's going to loan a 1 to this guy. All right? So 10 minus 7, that 0 becomes a 10. 10 minus 7 is 3. Okay? Now this guy borrowed a 1. He became a 10, but he had to loan a 1 over here, so that becomes 9. 9 minus 8 is 1. And this guy had to loan a 1 to these guys, so he becomes an 8. 8 minus 2 is 6. Okay, and this didn't need to loan to anyone, so it stays an 8. And there's your answer. Now the way you check your work on subtractions is you add going from bottom to top. So 3 plus 7 is 10. There's your 10 right there. You take the 1 and you bring it down here. We're just doing an upside down addition. 1 plus 1 plus 8 is 10. There's your 0. And you bring the 1 down here. 1 plus 6 is 7, plus 2 more is 9, so that works. You don't carry anything over to here, there's no carry, so it's 8 plus 0 is 8. So since these two numbers added together give you that one, you know you did the subtraction correctly. Okay, go ahead and do the next two. Do them both at the same time. Pause, and I will come back with the solutions to both of those. And we're back, and I'm going to do these two silently. Okay, and that takes care of decimal addition and subtraction. If you have questions on any of these, you can just bring them up in class. Okay, now we're going to do decimal multiplication. Decimal multiplication, unlike addition, you do not line up the decimal points. You line up the columns just like you would in regular multiplication. Don't worry about where the decimal points are. You're going to forget they're even there until the very end of the problem. So let's go ahead and do this. Okay, so this column lines up. These two numbers I could have done a better job, but these two line up, and then the 6 is over nothing right there. Notice though that the decimals are not lined up with each other. Don't worry about that. So now you do it. It's a good chance to practice. I'd like you to do this manually, okay? And that's when it says compute manually, I should have pointed out earlier. It means do it by hand, okay? Doesn't hurt you to do some of this by hand. So 4 times 7 is 28. You carry the 2 up here. 7 times 7 is 49 plus 2 is 51. You carry the 5. 7 times 6 is 42 plus 5 is 47. You put a 0 placeholder there. Now 3 times 4 is 12. You carry the 1. 3 times 7 is 21, 22. You carry the 2, and 6 times 3 is 18, plus 2 is 20. And now you add 8, 3, 9, 4, 2. You have 5 digits there. So how do you deal with the decimal? You count how many digits in your multiplicans here. How many are to the right of the decimal point? So here we have 1, 2, and down here we have a third one. 1, 2, 3. So what you do is you start over here, and you put the decimal way over on the right, as far right as you can, and you come back 1, 2, 3 places. So the decimal goes in between the 4 and the 9. So just to write that a little more neatly, the answer would be 24.938. 24.938. And that's your answer. So you save the decimal, adjusting the decimal until the very end of the problem with multiplication. Okay? Let's do this one. So okay, so you see again I lined up columns there. So now we multiply. 28, carry the 2, that's 32, plus 2 is 34. So we have a 3 to carry. 4 times 0 is 0, plus 3 is 3. And 4 times 2 is 8. The 0 there. 3 times 7 is 21. You're going to carry the 2. 3 times 8 is 24, plus 2 is 26. And 3 times 0 is 3, but you have the 2 from the 26, that goes there. And 3 times 2 is 6. Okay, the zeros are just going to all zero out, so don't even worry about that. Now, I crowded myself here a little bit, so I'm going to write this a little off to the side. I'm just going to put it over here a little bit. So 8 plus 0 is 8. 4 plus 1 is 5. 3 plus 6 is 9. 8 plus 2 is 10. You carry a 1. 1 plus 6 is 7. So again, we have 5 digits. This time we have 1, 2, 3, 4, 5 digits to the right of the decimal points. There's the decimal, 1, 2 digits there. There's another decimal, 1, 2, 3 digits there. That's a total of 5 digits. So we put our decimal, start way over there, and we come back 1, 2, 3, 4, 5. And the decimal goes in front of the 7. Okay, so I'll just write it here more neatly. Usually you write with a leading 0 in front of a decimal. So that's going to be 70958. And that's your final answer. Okay? All right. You go ahead and do this one. Pause, and I'll come back and do it silently. And we're back, so let's go ahead and do this last one. Okay, and that is our decimal multiplication. Finally, we're going to do decimal division. Students hate division. They hate long division. A lot of them do. Maybe you're not one of them. So we're going to do it, and we're going to do it with decimals. It's important you understand the process. Occasionally, you will have to do this by hand. On the multiple choice section of the AP exam, they do not let you use calculators. So you need to practice your hand calculations. So they're not number intensive, but any calculations you have to do, you're going to have to know how to do by hand. So we are going to practice these. Okay, so here we go. The division of decimals requires that the decimal point on the divisor, that's this one, the number outside the bracket, be on the right side of the number. So it has to be over here. There are 4 steps to division. You divide, you multiply, you subtract, and then you pull down. And then you continue to repeat that process until you're done with the problem. So, the decimal on the divisor out here is already to the right. We don't write it, but it's right there up against, we call that up against the wall. Alright, so now we're ready to just go ahead and divide. The only other thing we have to do is take this decimal and put it up top, directly above where it is down here. So let's do the first step. We divide. 23 goes into 46. And I'm going to teach you a little technique that I use. Some students like it, some students don't. It's a number line. And on the bottom of the number line is always the numbers 1 through 10. And on the top is the divisor and 10 times the divisor. So this is a 23, and 10 times 23 is 230. And I'll show you what this is used for as we go through these problems. You don't put this number up here. A lot of students make that mistake. They don't really understand the concept. You don't put that up here. So 23 goes into 46. Well, that's kind of an easy one. I think most of you can see it goes in exactly 2 times. But what if I didn't know that? This helps you to make estimates. Where between 23 and 230 is 46? It's about right there. So what number is that between 1 and 10? It's about 2. So what you come over here and do, and you may have to do a number of trial multiplications here. This one's an easy one. Whoops, that's a 23. So 23. Okay, so 2 times 3 is 6, 2 times 2 is 4. So yeah, 2 times 23 is exactly 46. So we did a division, 23 into 46. We guessed that the number was 2. We multiplied 2 times 23. That's our multiply step, excuse me. And then we put the 46 down here. Once we know that 2 is the correct number, we put it up top here. Now where do we put it? Well, 23 does not go into 4. It won't fit into 4. But 23 does fit into 46. So we put the 2 up above the 6, because that's the furthest digit to the right that we had to go to get that 23 to fit into the 46. So this goes into not 4, but it goes into 46, so the 2 goes above it. 2 times 23 is 46. Now we subtract, we get 0. And now we pull down, we get 5. Okay. And now we divide 23 into this number. But after we've done the pull down, we have the number 0, 5, which is 5. 23 does not fit into that. The mistake a lot of students make, even those who understand how to do long division generally, they make the mistake of going immediately and pulling down the next digit. That's wrong. Before you do that, since 23 did not fit into this number after we did this first pull down, then you have to go up here and put a 0. Okay, now you do the second pull down. That's 52. And we can see that 23 went into 46 exactly 2 times, so it goes into 52 2 times. Okay, and I give you the instruction, just arbitrarily do the following divisions to one place after the decimal. I just want to be sure you know how to handle the decimal. We're not going to worry about whether this should be rounded up or rounded down at this point. We're just going to truncate it. That means we're just going to stop. The moment we know we have the correct digit there, we're going to stop. So our answer is 20.2. Okay? All right. Let's go over to the next problem. And what we're going to do is, we said this decimal has to be at the right side of this number here. It has to be up against the wall here. So we do this 1, 2. That means we've got to move this decimal over 1, 2. Don't think that you just automatically move it to the end. That's not correct. You move it the same number of places as you move this decimal. So now we're going to rewrite the division problem as 12. And that's going to be 12 into the decimals now between the 5 and the 8. You can ignore this leading 0, so it's 25.8. Okay? And now that we have that decimal set, we put this decimal up here. And now you forget about the decimal for the rest of the problem. You don't even have to think about it. Okay? So now we get started. Let's draw our number line. A 1 and a 10 always go at the bottom. The divisor, which is now 12, it's no longer 0.12, it's now 12. And over here is 10 times the divisor, that's 120. It's just 12 with a 0 at the end of it. All right, so let's go ahead and divide. 12 goes into 25. Well, I think you can all see that one. But what if you weren't sure? You say, well, 25, where is that between 12 and 120? It's about right here. Again, that looks like about 2. So let's do 2 times 12. And that equals 24. Okay, so we're going to put a 24 here. Now, this number has to be smaller than this number. When you do the subtraction, you have to end up with a positive number. If this number is bigger, than this number, it means that this 2 was too big, and you have to go down 1. Okay, so we're going to subtract 25 minus 24, and we get 1. This number has to be smaller than this number. If it's not, it means that the 2 that you picked was too big. Okay? You had too much left over. But it is. So this number has to be smaller than this number, otherwise that 2 was too big. This number has to be smaller than that number, otherwise that 2 was too small. But both of those things are true. This is smaller than this is smaller than this. So the 2 goes up top. Where does it go? Well, we had to move over. 12 doesn't go into 2, but it does go into 25. So we had to move over to that digit, so we're going to put the 2 there. 2 times 12 is 24. We did the subtraction. Now we do the pull down. You do not ever pull down the decimal point. Forget about the decimal point even being there. I know it's not quite lined up, but we're pretty good. Okay, so now the 8 comes down to make it 18. 12 goes into 18. You all know that. It goes in one time. Not exactly one time, but it goes in one time. So you put a 1 up here. Okay, and if you want to just verify, so 1 times 12 is 12. Okay, so this number is smaller than this number. That means 1 is not too big. Now you do a subtraction. You get 6. 6 is smaller than 12. That means that this number is not too small. Okay, but we have one place after the decimal, so we really don't have to do, now that we've verified 1 is correct, we don't have to do anything further. Okay? All right, this is a check problem. I'll let you do that one on your own. I'll do this last one. Looks kind of icky, but it's not too bad. So what do? So we move this over 1, 2, 3, 4, 5 places until it's up against the wall. We move this one over 1, 2, 3, 4, 5 places. Notice there's an empty space there, so we plug that with a 0. All right, so what do we have? Well, here all these leading zeros go away when you put the decimal there, so you have 6 divided into, and again, these leading zeros go away, so it's going to be 6420. The decimal's here, and since we want to go one place after the decimal, we're going to go ahead and put a 0 there. We're going to put the decimal up here, so we never have to deal with the decimal again. We're done thinking about the decimal. So let's go ahead and do the division. 6 goes into 6 one time. 1 times 6 is 6. Subtract, you get 0. Now you pull down the 4. 6 does not go into 4, so we did our pull down, and it's still not a big enough number to fit the 6, so now you have to come up and put a 0 there. Don't forget that. Now you do the second pull down, you bring the 2 down to make it 42. 0, 4, 2 is 42. 6 goes into 42 7 times. 7 times 6 is exactly 42. Subtract, you get 0. Everything else after this is zeros. So this is going to be a 0. This is going to be a 0. So it's 1070.0. Okay, and that's how you do division. So work on this one and come into class with that one done. Okay, now we're going to get into a concept called scientific notation. Scientific notation is a means of writing really large or really small numbers in kind of a compact form. You're going to live in the world of scientific notation in this class, so get used to using it and manipulating it, multiplying, dividing, and so forth. Okay. This number is called Avogadro's number. Let me do this one first because it gives you an example of how scientific notation is helpful. If you wrote this big long number, which we use all the time in chemistry, if you wrote it out like this, it would be crazy if you had to do that every time. So scientific notation, what you do is, well, let me just go ahead and write this one. I'm going to do this one for you. It's 6.022 times 10 to the 23rd power. So you can see how much shorter that is to write than that. And so that's the advantage of scientific notation, and we use it all the time. So how do we do scientific notation? How do we write these decimal numbers in scientific notation? Here's what you do. You identify where is the decimal right now. Well, you don't see a decimal there, but you know there's an implied decimal at the end of the problem. And let's just read this. Okay, anyway, I've already discussed that. So what you do is you need to move the decimal so that this number is a number between 1 and 10. Technically between 1 and 9.9999. It can't be 10. But between 1 and 9.999. So how do we do that? Where would we move the decimal? We would move it over 1, 2 places to right there in between the 8 and the 7. So now we have 8.76. So that's a number between 1 and 10. So now you multiply, and you always do this, it's times 10. By the way, in scientific notation, we do use the X as the time sign. That's just tradition. That's the way they do it. You don't put a dot or anything else, okay? So the next thing is, what is the exponent? You simply ask yourself, how many places did I have to move this decimal? I had to move it 1, 2 positions, so this is going to be a 2. The only final question you have to ask is it a positive 2 or a negative 2? Negative 2, by the way, wouldn't make it a negative number. We'll talk about that in a second. But since the number we started with is greater than 1, just ask yourself that question. Is it a number greater than 1? Yes, then that's a positive number. That exponent is positive. So there's your answer for that. Okay? All right, how about this one? 45,670. First thing you should do right away is just write it without that comma. Commas are only used for readability. In some countries, they actually are the same as decimal points in this country, but but in the United States, they're just to make the number easier to read. Okay, so what do you do? What do you do with this number? What did we do here? Identify where the decimal point is. It's right there. And you move it over so you make this number between 1 and 10. So 1, 2, 3, 4. So the number is now 4.5670 times 10. Okay, and very simply, how many places did you move it? 1, 2, 3, 4. So this is a 4. And is the number we started with a number greater than 1 or less than 1? And the answer is it's greater than 1, so that makes it a positive 4. So there's your answer. What this is really saying is 10 to the 4th is 10,000. If you multiply 10,000 by 4.567, you'll get 45,670. Okay, let's do this one just for the heck of it, even though we already did it. The decimals here, we're going to move it over. I'm not going to draw the loops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So I moved it to the right 23 places, and I made that 6022 times 10, and it was to the 23rd, and quite obviously that's a number bigger than 1, so that's a positive 23, and there's your answer. Okay, now let's do some numbers less than 1. Notice these are all positive numbers. They're between 0 and 1. Now what you think of as decimal numbers. They're between 0 and 1. Okay, so these numbers were all greater than 1. These numbers are less than 1, but they're not negative numbers. All right, so how do we do this? Well, you already see where your decimal point is here in these. That makes this a little easier. Where do you move it? Well, if you want a number between 1 and 10, you move it over one space to the right. So you have 3.46. And that's going to be times 10. And you move the decimal over one place. Okay. And in scientific notation, you should write the exponent of 1 if it is 1. This actually isn't 1, though. Why? Is that a number greater than 1? The number we started with, is it greater than 1 or less than 1? In other words, between 0 and 1. The answer is it's less than 1, so that makes this a negative 1. Okay, that negative does not make this a negative number. If it were a negative number, you'd put a negative sign out here. That would make it a negative number. This means it's a positive number between 0 and 1. Okay, go ahead and do this one. Pause and do this one. Okay, and we're back. So what do we do? 1, 2, 3, 4, 5, 6. 4.31 times 10. You had to move it 6 places. And this number up here is a number, the original number is a number less than 1, so it's a negative 6. Okay, and I tell you what, I'm going to turn this into a check problem. You do this one on your own. Okay, let's keep rolling. Now we're going to do it in the other direction. We are going to turn scientific notation numbers into regular decimal numbers. Now, if you're working in chemistry and you're working in scientific notation and you come up with an answer in scientific notation, you never, under ordinary circumstances, have to turn that into a decimal number, just a regular number, in other words. However, an answer on a multiple choice test might have it represented as a regular number, not scientific notation, so you ought to be prepared to know how to do that. Okay, so what do? You take, this is called the coefficient. I haven't defined these terms yet. The 10 is called the base, and the 4, of course, you know, is called the exponent. So we take the coefficient and we just write it here. And rather than memorizing positive is right, negative is left, all that, you just ask yourself, is 10 to the 4 going to be a big number or a little number? It's going to be a number bigger than 4.97 or smaller? And the answer is pretty clear. 10 to the 4th is a big number. It's 10,000, right? So what you got to do is, that tells you which way you move your decimal. Which way you're going to move this decimal so that you get a bigger number than 4.97. And I think you can all see you move it to the right. 1, 2, 3, 4. And then you can put zeros in there. And then you can rewrite that number as 49700. 49,700. Okay? And that's the answer. All right. Go ahead and do these two. do them together, and I'll come back and do them silently. So go ahead and pause. Okay, and we're back. So let's go ahead and do these two. Here I'm not going to do these silently. I want to be sure the explanation is clear on this one. So you can see this is going to be a really little number. It's a decimal number because it's a negative. So if I want to make it a number smaller than this, which way do I move the decimal? So I'm going to move it 1, 2, 3. You put zeros in those spaces. The decimal's now here. Usually you write in science, you write any decimal number like this with a leading 0. Okay? That's not one of these two zeros. It's just its own 0 out in front over here. So now you have 2 zeros here, and 711, and there is your answer. Okay? I'll do this one silently for you now. Okay, so you can see this is going to be a number bigger than, it's going to make this number bigger, so you move the decimal to the right there. Okay, there's your check problem. You go ahead and do that one. Okay, now we're going to multiply scientific notation numbers. It's really not that hard. Sometimes there's a little twist to it, and you do have to be careful with the exponents. So let's go ahead and do this, and here's what you do. The coefficients in a multiplication problem, you multiply. So I'm going to put a times sign there between the 2 and the 4. The exponents you add. So I'm going to put a plus sign there between that 2 and that 5. And simply that's it. Now remember, your coefficient has to end up being a number between 1 and 10. So keep that in mind as we do these. So 2 times 4 is 8. And then it's times 10. And the exponent is going to be 2 plus 5 is 7. And that's the answer. Okay, pause and do the next one. Okay, we're back. So we're going to multiply 5 times 3 is 15 times 10. And then we have 9 plus 2 is 11. Okay, now there's a twist here. This is not a number between 1 and 10. Where is the decimal in that number, even though you don't see it written? Where is it? Yes, it's behind the 5. So to make that a number between 1 and 10, you move it over one place to the left there, and now that becomes 1.5. So now 1.5 is a number between 1 and 10. So here's the way you reason this. You made this number smaller. You went from 15 down to 1.5. So to compensate for that, you don't want to change the value of the answer. You want it to be the same value. So in order to compensate, you got to make this number bigger. And that's by increasing it by 1. In other words, going from 15 to 1.5 is dividing by 10. And going from 11 to 12, remember, these are exponents. These are multiplications of 10. So going up by 1 is multiplying by 10. So you divided this by 10, you multiplied this by 10. So now that this number is exactly the same as this number above it. Okay? Alright, so that's how you adjust the decimal. Okay, go ahead and do this one. And you can use calculator on this, but I'd like you to use the calculator just for the coefficients. I want you to do the calculation on the exponents. Okay, pause and go ahead and do that one. Okay, and we're back. Alright, so let's do a little multiplication here. We got 2.8 times 4.3, and that gives us 12.04 times 10. Now you got to be careful on the exponents. It's negative 2 plus 5. I find it easier to write it this way. 5. Keep the negative sign attached to the negative 2, or to the 2. Yeah. And 5 minus 2, which equals 3. Okay? So be careful on negative signs up there. So that's going to be times 10 to the third. Okay, we see, however, that 12.04 is not between 1 and 10. So we're going to move this decimal over here to make it 1.204, and that is a number between 1 and 10, times 10. Okay, so we made this number smaller. We went from 12 down to 1.2, so we've got to make this number bigger, and you increase it by 1. You increase it by as many places as you move the decimal, but so far we've only moved the decimal, had to move the decimal one place, so this increases by 1. Okay, all right. Let's do this one down here. Now this is what would be a negative scientific notation number. It has a negative sign out in front of the coefficient. So pause and go ahead and do that one. Okay, we come back. We have a negative times a negative, which is a positive, so that's going to be 29.24 times 10. Okay, and be very careful with this. Negative 2 plus negative 5. Okay, so negative 2 plus negative 5. Okay, what that means is you start at the number negative 2 on the number line, and you move to the negative direction 5 more places, so that would be negative 3, negative 4, negative 5, negative 6, negative 7. So that's going to be 10 to the negative 7. Okay, again, we have to do a decimal adjustment. So we need to get the decimal over here to make it a number between 1 and 10. So 2.924 times 10. Now we made this number smaller, so we have to make this number bigger. Remember, bigger though, a bigger number is going in the more positive direction. That means you're heading towards 0. So be careful. It's not negative 8, it is negative 6. Negative 6 is bigger than negative 7. Okay, and there is your answer for that. Okay, go ahead and do this one. That'll be a problem that I checked in class. Okay, now we're going to divide some scientific notation numbers. And again, you'll be doing this a lot in chemistry. Get good at it. Okay, here we go. So what's the rules for this? It's just the opposite of multiplication. You take the coefficients and you divide them. So you divide 8 by 2. You take the exponents and you subtract them. So the top one minus the bottom one. That's a little minus sign right there. Okay? So let's go ahead and do this. 8 divided by 2 is 4 times 10. 5 minus 2 is 3. And that's your answer. Okay? Go ahead and do the next one. Pause and do the next one. And we're back. So you can use a calculator for the coefficients. So we have 6.2 divided by 2.7, and that gives us we'll just round it to 2.3. And you see that is a number between 1 and 10, so we're not going to have to adjust the decimal. But be careful on the exponent. Times 10 to the what? 5 minus negative 2. Minus a negative is a positive, so that flips it to 5 plus 2, which equals 7. So you put the 7 there, and that's your answer. Okay? All right, let's do the next one. Pause and do that one. Do this one right here. And we're back. So let's go ahead and divide those two coefficients. 2.5 divided by 4.6, and that gives you 0.54, 0.54. Times 10, and again, I would not try to do these in your head unless you are really sure of yourself. It's minus 3 minus negative 8. A minus minus becomes a plus, so it's minus 3 plus 8. And I always like to turn these around. That's equal to 8 minus 3. Just keep the negative sign attached to the 3. And that equals 5. Be careful. Don't try to do those in your head. So that's to the 5th power. Now, this is not a number between 1 and 10. In this case, this is the first time we've seen this, we have to make this number bigger. We have to move the decimal over there to make it 5.4. Since we made this number bigger, we have to compensate by making this number smaller. So it goes from 5 down to 4. And that's the answer for this one. Okay? Good. Keep moving. Notice this word check up here. That's for this guy down here. So that's the one that's going to be your check. So let's do this last one here together. 9.94 divided by 6.2. And that's 1.6. So we're not going to have to adjust the decimal. 1.6 times 10 to the negative 8 minus 2 equals negative 10, negative 10. And that's that. Okay, so go ahead and do this one for your check problem. All right. Let's move on. We're going to do some exponents. And I want you to use your calculator. And I want you to practice doing these on the calculator. And I'm going to show you on the screen here how to do these on the standard TI-30 calculators that we have. So let me show you how to do that. Let me just show you a number squared, any number squared. If you take the number 10 and you want to square it, you simply have an x squared button. That's really easy, x squared, and then you have to hit equals. If it doesn't square it, whoops, and the glare is, I'm going to shut this off, okay, for this portion. So 10 to the 2 is 100. Hitting the x squared doesn't bring you the answer. You had to hit the x squared and then the equal sign, okay? Now, what about 10 to the 4th? Well, that's a little different. There's no x to the 4th sign. There's no x to the 4th button. So what do? You use the caret or the hat symbol here. And so what you do is 10, and then this little hat here, the little caret, and that's to the 4th power. And you push equals, and there's your answer, is 10,000. So this is 10,000. Okay. Go ahead and do the next one. You have 10 to the negative 4th. Let's see if I can show these both at the same time. Let me clear that. Okay, so 10, caret. Now be careful. You don't use the minus sign for a negative number, to show a negative number. You have to use this. Let me get on screen here. I'm off screen. Okay. You don't use the minus sign for a negative number. You use this down here. Okay, so let me bring it back on screen. So I'm pushing the button down at the bottom, the negative sign, and the 4, and then I hit enter, and I get 0.0001. So, and again, the leading 0 is done by convention. Get used to doing it. It's not a significant figure, and we'll talk about that very soon. Okay. Now, how about 16 to the 1/2 power? Well, some of you might recognize that 1/2 is 0.5. You could do it that way, but what if you didn't recognize that was 0.5 or it was some other fraction that wasn't quite as obvious? So what do? We say 16, caret, parenthesis, 1 divided by 2, end parenthesis, and then hit enter, or equals, and you get 4. So that's really the square root. This is a way of writing the square root of 16. Okay, that's the same. Those two are the same. So the answer to that is 4. Okay, try doing the next one. Pause and do the next one. What do you got? Okay, so here we go. We got 16, caret, parenthesis, negative 1 divided by 2, end parenthesis, and you get 0.25 or 1/4. Okay. Okay, how did you get there? Well, remember, 16 to the 1/2 was 4. The negative sign inverts whatever your answer is. It takes the reciprocal, okay? And the negative on an exponent takes the reciprocal. So basically, it takes that 4 and flips it over to make it a 1/4. Okay, next. Try to do the next 3 on your own, and I'll just roll through those in a second, okay? And we're back. Okay? Always remember to pause whenever I stop for that. I should have said pause. Okay, so now we are back. Okay, here we go. this one. And of course, any number to the 0 power, with the exception of 0 itself, any number to the 0 power is 1. Don't get confused on that, okay? If you don't believe me, do it on your calculator. 16 caret 0 equals, boom, there it is, 1. Okay? All right. Now we're going to finish up by doing some roots down here. And remember, exponents and roots, you could do a root by calling this 49 to the 1/2 power. Just like we call this 16 to the 1/2 power was the same as the square root of 16. Okay, so let's go ahead and do that. So how do you do a root? Well, you notice right above the x squared sign, there's a square root sign. So if it's a square root, you can use that. And you get to that by hitting the second key up here, the light blue key, and then hitting the x squared key. That means it's going to do the secondary function here, which is a square root. Okay, so that was 49. Move it out of the way here. So that's 49. Actually, what you have to do, and this is a little tricky and I almost blew it, you have to hit the second and the square root first. Notice what it gives you is a square root symbol and a parenthesis. Now you got to put the 49 in. So you actually have to hit the function before the number. It's usually not that way on most calculators, or even on this one for most other functions. Now don't forget to close the parenthesis. Okay, there you go. So now I've got the square root of 49, and that's going to be 7. Okay, how about this one? The cubed root of 27. I'll show you two ways to do that. Get this focused again. Okay, how do you do the cubed root of 27? Remember, the cubed root of 27 could be written as 27 to the 1/3. So one way I can do that problem is to say 27 caret parenthesis 1 divided by 3 end parenthesis equals, and that gives me 3. Okay, the other way to do it is to use the root function that's something other than a square root. And there it is right there. It has a little x above the root sign there. Now the trick to that is you have to put your root in first before you hit the function. Okay, so watch what happens. I want a cubed root, so I'm going to push a 3. Then I'm going to push second. And then I'm going to push this above the caret there, that. So it looks like that. Well, what they're really saying is that the 3 is really that little x up there. So now it doesn't give you a parenthesis. Notice that. I recommend you put things in parentheses when you go inside a root, although it really isn't necessary in this case. Then you got 27, you close the parentheses. So that's how you would put a cubed root of 27. You have to do the 3 first and then bring up the function. And if you hit that, you'll notice you also get 3 as your answer. Okay? Okay, do the 5th root of 32. You can do that either way you want. I'm going to use the root sign. Go ahead and do that. Pause and do that. Okay, you could have done 32 caret 1 divided by 5, 1/5, and that would have given it to you, but let's do it. So again, we have to push the root number first, what it is. Then we go to second up here, and then we go to caret, and it's going to give us the secondary function above caret, and then I like to, again, put it in a parenthesis, 32, and that's going to be the 5th root of 32 is 2, okay? 2 times 2 times 2 times 2 times 2. 5 times 2, not 5 times 2, but multiplying 2 by itself 5 times will give you 32. All right, so the answer to this one is 2. And finally, last but not least, let's go ahead and do this one. All right, so what are you going to do? You're going to put 0.5. You're going to do second and a caret right there. I'm going to put it in parentheses, 10, close the parentheses, and I get, 100. That number actually got bigger. It's because this is a number less than 1. You'll rarely ever see that, okay? Anyway, so that concludes our lesson. It was a fairly long one, just over an hour. Again, you don't have to watch the entire video of something like this. You just watch what you need to watch to get you through this. And some of you probably could do all of these problems without even watching this video. All right, so you'll see these for your problem sets every day. You should never feel frustrated sitting at home. On the other hand, if all you do is copy the answers, you're not going to improve. You've got to struggle with these problems a little bit before you go to the solutions, okay? It's just, you know, that's what's going to get you on pass on the AP test, not copying problems. So be sure you do that. Be sure you learn how to teach yourself properly. Okay, so we'll see you in class.